Welcome to the video on quantum. You've probably heard this word quantum before in quantum mechanics and quantum physics. Let's talk about what a quantum actually is. A quantum is an amount of energy. It's a very small amount of energy, but it's the amount of energy required to excite an electron to another energy level. What does that mean? Electrons start off in the lowest energy level possible. That's according to the Aufbau principle. But let's say that one electron gets hit with some energy, like some electricity comes in and hits it. That electron can be moved temporarily to the next energy level. And it takes a quantum of energy to do that. So this is a quantum right here. Now, it doesn't matter which energy level they're starting from and which one they're ending. They could have one of these anterior ones get hit by electricity, and the first level electron can jump up to the fourth level. And it doesn't have to go to the fourth level. You could have an electron go from the second level to the third level, and so on and so forth. Any electron can go to any other level. It depends on how much energy you get hit with. But it does have to go up. So you have to go 1 to 2 or 1 to 4 or whatever. You can't go down. What happens, and so that is a quantum. Now, the electron doesn't stay there because it's not following Aufbau principle. It's not in the lowest energy level possible. This is called the excited state when the electron is in the blue position. Once the electricity stops hitting that electron, it will fall back to where it was before. When it falls back, it releases energy, and it releases a quantum. So a quantum is just an amount of energy, and it can be either the energy absorbed to excite an electron to the next energy level or another higher energy level, or it could be the amount of energy given off when the electron falls back down to ground state. And you may have seen this term on your quest homework. Ground state just talks about all the electrons in the lowest possible energy level configuration, as opposed to excited state, which means the electrons could be anywhere, and we don't try to do electron configurations for that. Now, one thing I want to point out is quantum is not the same every time, because the amount of energy required to move from one energy level to another energy level is different depending on which energy level you're starting and stopping. And I tried to draw this picture somewhat to scale. The distance between the first and second energy levels is greater than the distance between the second and third, which is greater than the distance between the third and the fourth, and so on and so forth. So the amount of energy that is required to move the electron from the third to the fourth is not as much as the amount required to move from the first to the second. So let me write this down. So the quantum to go from 3 to 4 is less than to go from 1 to 2. The quantum for 1 to 2 is a higher amount of energy. And this is just another way of depicting that. So let's say your nucleus is here. This would be a quantum. Well, not from the nucleus, but from first to second would be a quantum. And this would be another quantum. And this would be another one. But each of these quanta being the plural, quanta, each of these quanta are different from each other because it depends on which one you start with and which one you end with. And if you went all the way from the first to the fourth, you would need all that energy. So that is the basic definition of a quantum.